This student is working on a programmed lesson in mathematics. She reads a small amount of material, answers a question, then checks the answer. She continues through the lesson at her own pace. Each step, or frame, is designed to build on what has come before, and at each step, the student makes responses which the preceding material has prepared her to make. This pattern for presenting instruction has been effective in many applications. There are indications, however, that this success is primarily due to extensive student tryouts and revisions, rather than to specific details of program design. We shall follow through a program development process which places strong emphasis on tryouts and revisions to show how it can produce a successful instructional program. This programming team is taking the first step in designing a program, specifying objectives.
We're going to have to express the objectives in a somewhat more behavioral way to describe what it is that children are supposed to do.
Well, if that's too general, I think the understanding night and day breaks down into two main points. Let me illustrate.
Rather than speaking of what the student must know or understand, programmers specify objectives in terms of what the student must learn to do, whether it be operating a machine, discussing a fine point of history, or explaining how movements of the Earth and Sun cause night and day.
Now, the second main point has to do with rotation. And I think there the student should be able to answer a question like this: why isn't it night on this side of the Earth all the time, since it's in the shade?
Specifying objectives for a program can involve many meetings of this type, extensive research in relevant source material, and consultation with subject matter experts.
What about an objective that's as specific as this one, though? Students should know whether nights are longer in California or Chile on December 22nd.
It seems pretty detailed to me. What do you think, Dave?
I think, I certainly think we wouldn't want to spend much time in the program teaching that specific item, but on the other hand, I do think it's a very good test item relating to the general objective of how the lengths of night and days in the two hemispheres change with the seasons.
Well, look, we've already made up a lot of specific test questions, just like this California.
An important part of specifying objectives is writing the final examination for the program. Often called a CRITERION test, this exam will ultimately be used to evaluate how well the program meets its objectives.
Okay, what about teaching the order of the four seasons?
Well, we're pretty sure they'll already know that objective.
I thought we could leave it out of the program for now, and if tryouts of the first version indicate that this isn't part of their prior knowledge, then we can always include it as one of the objectives.
Okay.
Meetings and extensive research continue until the programming team has estimated the student's prior knowledge and has spelled out what students should be able to do at the completion of the program. Although a program on Earth-Sun relationships would cover far more objectives than are shown here, we will use these topics to illustrate the remaining steps in developing a program. This flow chart shows each major stage in the program development process. Once the objectives have been specified, the programmer shifts attention to the sequence of topics within the program. An analysis of the structure of the subject matter is used to determine interdependence of topics. This analysis, together with estimates of the skills students will bring to the program, guides the programmer in deciding on a tentative sequence. In order to spell out exactly what will be expected of the students at checkpoints throughout the program, many programmers draft a series of test questions called CRITERION frames, which cover major topics in the program. Correct student response to a CRITERION frame like this one would indicate that he has learned one aspect of the distinction between rotation and revolution. Because criterion frames are designed to test whether the student has learned a specific point, they do not contain any teaching material. Placed in the sequence in which the topics will be covered, the criterion frames form the basic outline upon which to build the program. At this point, the programmer has specified what the students should be able to do, both at the completion of the program and at checkpoints throughout the program. The next stage is to prepare teaching frames. The programmer uses statements of objectives, the criterion frame outline, and subject matter references as guides in developing teaching frames. Individual teaching frames contain explanations or examples or both. They also contain questions, which are designed to focus the student's attention on what is to be learned and to give him relevant practice. Students' answers to teaching frames, related criterion frames, and items on the criterion test will be used later to evaluate whether students actually understood the teaching material. Once the teaching frames are inserted in the criterion frame outline, the first draft of the program is ready for evaluation. From now on, the program will be improved on the basis of trial runs with students, starting with the individual tryout phase of program development. Each series of individual tryouts is carried out with 3 or 4 students who are representative of the group for which the program is intended. The students are selected on the basis of test scores, age, grade level, and other factors, so that the range of abilities in the group is reasonably well represented. Having a small number of students work through early drafts of the program provides so much information that these tryouts are considered to be an integral part of program writing. Throughout this phase, programmers work closely with the students on problems that arise.
I noticed you didn't make any errors on these first frames. Did you have any trouble with this first section on rotation and revolution?
No, I could do it okay, but some kids probably would have a hard time with rotation and revolution.
Why do you think so?
Because they sound alike, but you never use them together for the same thing.
Okay.
The programmer tabulates the student's performance and subjective reactions. Revisions are not made on the basis of a single remark like this, but often such remarks suggest problem areas worthy of further investigation.
What's rotation? Rotation is spinning around on an axis.
What's revolution?
Revolution is spinning around on something too.
On what?
An axis.
Are rotation and revolution the same thing?
Well, I guess they're two different words that mean the same thing.
What's the trouble?
Well, I don't know. He told me to tell you, and I don't understand something.
Okay, what don't you understand now?
Well, I don't understand the difference between these cards on rotation and these cards on revolution.
Okay.
When trial students consistently have difficulty on the same topics, the programmer has a clear indication that revision is necessary.
You got everything right up to frame 7, and then you didn't know the difference between rotation and revolution.
That's the first time I saw that there was a difference. In the beginning, if you had told me that revolution and rotation was two different things, I would have learned it better.
In addition to pointing out problem areas, students often give useful suggestions on how to revise sequences. Although tryouts on only a small portion of the program have been shown for illustrative purposes, the programmer will at this point have data on many trouble spots. He considers the student's performance and comments in preparation for making the first major revisions in the program. Modification of the criterion frame outline and of some teaching frames is usually required. Often entire sequences will be deleted or added. The original sequence on rotation and revolution was designed to treat rotation first and revolution second, followed by criterion frames on the difference between rotation and revolution. Because students failed to get this distinction, and because some of them even failed to see that there was a difference, the programmer restructured the sequence to treat the two concepts simultaneously, thus drawing the distinction from the very beginning of the sequence. In this revision, the programmer increased the complexity of each frame and decreased the number of frames. Other revisions could involve adding frames or making frames less complex, according to the particular problem. The new sequence and other revisions are inserted into the program in preparation for the second round of individual tryouts. Members of the programming team follow the progress of this new group of students, just as in the individual tryouts of the first draft.
How'd the first section go?
I got all the answers right, but I don't know how long I can remember the difference
What difference?
between rotation and revolution.
Do you think we should have given you more practice?
Yes, I guess so.
Revision of the program to eliminate one flaw often reveals other problems. Each successive set of revisions based on individual tryouts moves the program closer to its objectives. Individual tryouts are continued as long as they provide useful information for revisions. The revised program, with the cooperation of school administrators and teachers, is then tried out in classroom situations. In contrast with individual tryouts, which are primarily developmental in nature, group tryouts are designed to check out or validate the program. In group tryouts, the students do not discuss the program with the programming staff. This permits a check to ensure that students have not been unwittingly tutored in the individual tryout sessions. Written responses to the program frames and the criterion test provide data on the performance of a broader sample of students than could be used in the individual tryout stage, and make possible more accurate predictions of how well the program will work in its final applications. The programmer cannot keep close track of his students in this situation. The tabulation of errors they make can provide useful information for further revisions. Consistent errors at this stage point out weak spots not revealed in individual tryouts. This error pattern clearly indicates the need for a revision of either frame 13 or of preceding frames. Some degree of recycling through the programming process is usually necessary at this stage. If, for example, the group tryout data reveal misevaluation of the student's abilities, modification even of the objectives may be required. If group tryout data lead the programmer to make extensive revisions, it is normal to evaluate these revisions with individual tryouts before going to the expense of further group tryouts. Whether the revisions are extensive or minor, the revised program must eventually be validated by group tryouts. Once validated, completed programs are presented in a variety of ways. Program textbooks are most frequently used since they are both economical and effective. Teaching machines, which are essentially program presentation devices, offer additional features including the use of film programs and synchronization of audio and visual materials. Whether programs are presented by teaching machine or textbook, their success in the classroom depends on methods the teacher uses to relate the programmed instruction to the total curriculum. Here, Mr. O'Brien uses lectures to support programmed instruction in mathematics. This and the following examples of classroom use of programmed instruction are excerpts from other films in this series. Miss Shedd carefully controls the learning environment so that her first-grade students can work successfully on their reading program independently. Miss Langdon's third-graders conduct experiments based on principles they studied in their science program. In this final illustration, Mrs. Kaplan's fourth-grade students build a dictionary of words they have invented, using prefixes, suffixes, and roots studied in a vocabulary program. The teacher's ability to relate the programmed instruction to the overall teaching objectives will determine the program's ultimate effectiveness. The initial effectiveness of the program is the product of the developmental process and of the decisions the programmer made at each step. Objectives and subject matter research, criterion frames, teaching frames, individual tryouts, revisions, more individual tryouts and revisions, group tryouts, and further revisions, final group tryouts, and a completed program. Not all programmers follow this exact procedure, nor are all programs developed with this careful attention to student performance. But a program which has been developed on the basis of student performance can be relied upon to produce predictable results. In teachers' manuals which accompany programs, conscientious publishers provide details about the kinds of students on whom the program was tested and the results obtained from these tryouts. This valuable information can be used by teachers to decide how best to integrate programmed instruction into their total curriculum.